Savannah River National Laboratory is the nation's leading research and development center for the Department of Energy's Office of Environmental Management and Office of Legacy Management. SRNL's Environmental and Legacy Management Directorate designs, develops, and tests processes, flow sheets, and equipment to support excess nuclear material storage, processing, and transportation, providing solutions for EM's 15 active cleanup sites, as well as sites transitioning to legacy management.
We've been doing this mission since the early days, the inception of the nuclear weapons program. So we've created the science and the technology behind the fuel material, between irradiating the material, and then the actual separation processes that allowed us to have the nuclear materials that were needed for the weapons. The EM mission is one that I think is a noble mission. We created the waste, we have to help clean it up. And it's something that is a large liability for the government. So anything we can do to help accelerate that, help move it forward, I think is great.
All nuclear materials are different. They all require some type of different surveillance. They're all packaged differently. So with each one of those come different challenges. We're working right now on 3013s, which are the containers that store surplus plutonium. There's a national 3013 surveillance program. We play a huge role leading that. Right now, one of the focus areas that we have in the ELM is looking at methods to safely dissolve some of the non-aluminum clad spent nuclear fuel stored at the Savannah River site. It's very unique, it's very difficult to dissolve, it's highly reactive, so it can't be exposed to air. So we're doing a lot of experiments right now to prove that we can safely dissolve that material. What's the throughput to be able to do it with a new flow sheet? We're also looking at hydrogen generation phenomena in aluminum-clad spent fuel, which is unique to the Department of Energy.
SRNL is also chemically separating the only irradiated Mark 18 target assemblies containing the rare isotope plutonium-244 for use as a certified reference material in nuclear forensics applications.
We're also recovering heavy isotopes of curium from the Mark 18s that will be used to irradiate in the high-flux isotope reactor at Oak Ridge National Laboratory to produce californium-252, which has numerous non-proliferation applications.
Long-term storage of nuclear waste in carbon steel tanks at DOE weapons production sites also poses challenges for corrosion control.
What do we want to monitor? What do we want to control in the tank to ensure that it can be stored for long periods of time? So went from an acidic stream to a caustic streams by adding sodium hydroxide, used inhibitor chemical additions to mitigate the pitting and the other types of corrosion that might occur in that tank. That program has been very successful at Savannah River. And we're taking that technology and applying it actually to the other sites in the DOE mission.
SRNL's proximity to real-world processing facilities at SRS takes bench-scale testing to full-scale on-site, fast-tracking the time it takes to deliver solutions for EM.
Our work is focused on immobilizing and treating the millions of gallons of waste sitting in large tanks as DOE started weapons production. The work we do basically improves how we process this waste residues. So when we have something that we implement, we get to see whether or not our ideas actually work in the field rather quickly. Some examples of that is we developed a proprietary antifoam in conjunction with Illinois Institute of Technology that's been deployed at DWPF. In addition, our efforts to improve the throughput of DWPF, we see immediately whether or not the things that we chose to try to implement are successful or not.
SRNL helped develop pioneering technologies to separate the low and high-level waste streams at SRS. High-level waste is stabilized into borosilicate glass at DWPF. The low-level waste is processed through SWPF before being moved and mixed with grout at the saltstone processing and storage facility. The grout recipe used at Saltstone is also modified to backfill empty waste tanks at SRS and other DOE sites.
So my work involves technology development in treating low-level waste and true radioactive waste. This is beneficial for current and future nuclear industry, including power reactors, medical and isotope production facilities, as well as defense programs.
Once emptied, SRNL scientists develop safe, effective, and efficient flow sheets to operationally close the underground waste tanks.
So what SRNL did was work very closely with the tank farm contractors to look at characterization techniques, cleaning techniques, retrieval techniques to ensure that we could get the most material out that we can.
An aqueous self-compacting zero-bleed structural grout specifically developed by SRNL is then backfilled to operationally close and stabilize the waste tanks.
SRNL is well positioned to leverage decades of expertise in safe and environmentally responsible waste treatment technologies.
If you think about nuclear energy, the renaissance that is occurring there, some of our technologies are directly applicable to that. So our mission is to how do we get ourselves involved with the commercial industry to help them solve these really difficult challenges.
Taking a lot of that knowledge on back end of the fuel cycle, all of those processes are critical in the advanced reactor communities. For years, the site downblended HEU from spent nuclear fuel to produce LEU. We're now pivoting that to recover HALEU, which is a higher uranium-235 enriched material that can be used as feedstock for advanced reactor fuel.
As people understand how the nuclear technologies could benefit, particularly in reducing carbon dioxide emissions, people have started to look at these technologies again. And one of the issues that we have that we're trying to work on is how do you solve the back end of that? How do you treat the waste that these reactors will generate? And so our work develops new techniques, new processes to treat that waste and make it where you can close that back end and feel comfortable putting these new reactors in service.